Okay, on number 21, you're trying to evaluate 21 through 24. It's finishing up the evaluating logs without a calculator. So if you remember, one thing that you learned was that log base b of b to some power is just the power. So the log and the exponent, as long as their bases were the same, they cancel each other out because they're inverse operations, and you're left with just the power expression. So when I look at log base 9 of 81, I think, well, I can rewrite 81 as 9 squared, leaving me with an answer of 2. So I know that the evaluation of that is 2. Now on number 22, it's a little bit different because what we didn't do in the homework or the lesson, and you might all want to pay attention to this, is dealing with the base being larger than the what you're evaluating. So what you need to do is be able to think of it like this. Log base 81 of 9 equals what? So that's what I'm trying to find, right? If I convert this to exponential, then I go 81 to what power is 9? Because I want to be able to rewrite this as log base 81 of 81 to something. And I want to know what that something is. It would be advantageous for you all to pay attention. Now, if you typed it in, that's one thing, but you should know how to do it without a calculator, right? So when I think about 81 and 9, what can I do to 81 to get 9? And I don't mean like, it has to be like a single operation, not divided by 9. What operation can I apply to 81 to get 9? The square root, right? If I square root 81, I get 9. So that means I can rewrite this as 81 to the 1/2 power. So log base 81 of 81 to the 1/2, which is 9, is 1/2. So if I can rewrite it as that, then I can think of it like that. Okay? So, all right. Now on 23, so, okay, interesting. I need to rewrite this as that. Okay. If I let that equal a question mark and I rewrite it in exponential, then 343 to the, I don't know, equals 1/7. Well, here's what I know. I know that 343, why did I do that? I don't know why I did that. 343 is 7 to the what power? Third? So I know that 343 is 7 to the 3rd power. Interesting. I'm trying to think what can I... Okay, I'm going to kind of do some magic right here. 343 is 7 to the 3rd, and then I still want to know what that is, right? And then I know that 1/7 is just 7 to the -1, right? Are y'all with me on this one? Because this is a kind of an interesting one. So, if I were to rewrite this as 343 to the what? And it might even be easier with an x, so let me think of it like that. Log base 343 of 1/7 equals x, and x is what I'm trying to solve for. So 343 to the x power equals 1/7, which is 7 to the 3rd to the x, equals 7 to the -1. Well, the only way this is true, and this is just 7 to the 3x, is if the two powers equal each other, right? So if 3x equals a -1, that means x equals a -1/3, which kind of makes sense when I think about it like this. If I rewrote this as 343 to the negative power, that puts it in the denominator, right? Yeah? And then if I further take the cubed root of that, then I get 7. So, you're not even being able to see what I'm doing. So 343 to the -1 is 1 over 343. If I raise that to the 1/3 power, then I've got 7. So 1/7, yes, is the same thing as 1 over 343 to the 1/3 power, which is just basically 343 to the -1/3. So the answer is negative 1/3. Am I likely to put one like this on the test? Probably just Sis because I don't like him. But I would most definitely put one like 22 on it. Or the ones on the previous page that had the numbers. I'm not feeling the fraction though. Although this one's actually kind of easy. When I think about this, I want to rewrite 343 as 7 to some power. And I know that that's 7 cubed, right? I could just say 1 over 343 is 1/7 cubed. So the answer is 3. And I think if you type it in, that's what you get. Definitely ones like this, maybe not so much like ones like 23 and 24. All right, logarithms, graphing logarithms. Some of you guys did really well on the homework and got all the points, and some of you were hit and miss, okay? So I'm going to delineate exactly what my expectations are for graphing these. Okay, so first off, the transformation is the basic logarithmic function. And do you remember what a log looks like? Do y'all remember what logs look like? Remember they're the inverses of exponentials, right? So if an exponential looks like that, the log looks like that, right? Actually, it's more like that. Okay. But they are reflections across y equals x. Exponentials have a horizontal. Logarithms have a vertical asymptote. So, when I think about graphing this function, plus 2 on the inside means left 2, and we're actually talking about the vertical asymptote. So that horizontal shift, left or right, tells you where the vertical asymptote is. You need to label the vertical asymptote with the equation of what it is on the graph. Vertical asymptote is x equals -2. So then you need to be able to plot points, and I'm going to need specific points from you. So alpha window 5. Alpha window 5 gives me log base. So log base 2 of x plus 2 minus 4. And I go to my table. So the first error message is the vertical asymptote. And after that, okay, so I need the vertical asymptote. I need the first point after the vertical asymptote. 3 after that. I need the 3 points after the first point. Any whole numbers. And then the last point. So all in all, I have to have 5 points. I want more if it crosses a horizontal line that you can see. Okay? So, after -1, the next point I see is 0, negative. Oh, I gotta plot that one. Sorry. -1, -4. 0, -3. 1, -2.4. 2, -2. Okay, so that's the first point. The 3 directly after. I need to look for any whole numbers on my way to 8, and I see 6 is at -1, and 8 is at -0.67, so basically right in there. Okay? So if I sketch, or if I connect, then I connect them like this. Please draw an arrow at the end of your graph, and don't forget that it actually does need to go towards that vertical asymptote. It's not there for no reason, so you need to go towards it, don't go past it. Draw an arrow at the end of your function. And then it says, okay, graph each function, identify the domain and range, draw and label the asymptote. So draw domain and range. Okay, so domain is left to right. The farthest to the left it goes is -2, and the farthest to the right it goes is infinity. So you can either say -2 to infinity, or x has got to be greater than -2. Now, you need to be careful that you don't include -2 because we don't actually ever reach -2. That would be undefined. But then the range is low to high. The lowest goes negative infinity, the highest goes to positive infinity. So all real numbers or negative infinity to positive infinity. Okay. On number 26, the function is natural log of x plus 4 minus 1. So we are actually going to the left 4 and up 1. And it is natural log, which is log base e. But as long as you know where the natural log button is, you don't need to worry about that. The natural log button is beside 4. It says ln. So we type in ln of x plus 4 and then plus 1. But I know my vertical asymptote is over here at negative 4. So I'm going to go ahead and sketch that and label it. Vertical asymptote x equals negative 4. And I go to the table. So negative 4 is my first error message, and negative 3 is at 1. Negative 2 is at 1.69, so basically in there. 2.09, so basically 2. 2.38, so not quite to 2.5. Okay, that's the 3 directly after. I don't see any whole numbers, but I do see at 8, I'm at 3.4. I'd like to go ahead and at 4, it's 3.07, so it might as well be 3. You don't necessarily have to, but it's a very good idea that if you're going to cross a horizontal line that is graphed or on the grid, that you go ahead and plot a point around it. And then I know that it does this on this side. Okay, so domain and range. Domain is left to right. The farthest it goes left is negative 4. And range is up and down. It goes all the way up and all the way down, so all real numbers. Okay. Now let's get into sequences, geometric sequences. First, determine if the sequence is geometric. Okay, so that's the first thing. If it is, write or give the explicit formula, the recursive formula, the term named in the problem, which is a sub 9, the 3 terms in the sequence after the last one given. Okay. So first I need to determine if it's geometric. So arithmetic sequences had a common difference. Geometric have a common ratio. So what I do is I divide each term by the previous term. So negative 9 divided by 3 gives me negative 3. 27 divided by negative 9 gives me negative 3. And negative 81 divided by 27 gives me negative 3. So that is a common ratio of negative 3. So that means every time I go to the right, I multiply by a negative 3. So I'm going to multiply by a negative 3 more times to get the next 3 terms. So negative 81 times a negative 3, and that is 243, times a negative 3, negative 729, and then times a negative 3, it's 2,187. So far I've got part of my answer, the next 3 terms. I know my common ratio is negative 3, and I know my first term is 3. So if I know those things, then I can write my both recursive and explicit formula. So don't forget that your explicit formula the explicit formula for a geometric sequence is a sub n equals a sub 1 times r to the n minus 1. And then the recursive formula is a sub n equals a sub n minus 1 times r with the starting point given. Okay? So depending on what we're writing, that's the things we need to fill in. You need to fill in the first term and the common ratio in the first term. Both things are needed. Okay? So for the explicit formula, I've got a sub n equals a sub 1, which is 3, times the common ratio, negative 3 to the n minus 1. And then the recursive formula is a sub n equals a sub n minus 1 times the common ratio, negative 3, with a sub 1 equaling 3. Okay? You have to be very careful that you include all the information. You need to make sure that this is an exponent. You need to make sure that these are subscripts. If these are not subscripts and they're just written beside it, I will count off. And then the term named in the problem. So now it asks me to find the 9th term. And the easiest way to find the 9th term is to plug it in the explicit formula. So a sub n equals 3 times negative 3 to the 9 minus 1, which is to the 8th. So 3 times negative 3. Don't forget, if you're raising a negative number to a power, although if you're raising it to the 8th power, the negative goes away. If you're raising it to an odd power, then it doesn't really matter because it will be negative if you put the parentheses. But I'm raising it to the 8th, and I get 19,683. 19,683. So that is the 9th term. Okay? On number 28. It looks like I'm dividing by 4. And if I find the ratio, 4 divided by 1 is 4, 16 divided by 4 is 4, and 64 divided by 4 is 4. So I know that the common ratio is a positive 4. What are you looking for? Oh, someone put it in the wrong column. Okay, yeah. Okay, so the next 3 terms I'm going to multiply by 4. 64 times 4, and I get 256. Times 4, and I get 1,024 times 4, and I get 4,096. So those are the next 3 terms. The explicit formula is a sub n equals a sub n minus 1. Just kidding, that's the recursive. The explicit formula is a sub n equals a sub 1, which is the first term, 1, times the common ratio 4 raised to the n minus 1. And the recursive is a sub n equals a sub n minus 1 times the common ratio 4 with the leading coefficient, with the first term being 1. And then I want to find the 10th term, so a sub 10 equals 1 times 4 to the 9th. So basically just 4 to the 9th, and I don't have that in my power chart, so 4 raised to the 9th is 262144. Okay, on 29 it says, given the explicit formula, find the recursive formula, comma, common ratio, the first 5 terms, and the term named in the problem. So, I need the recursive formula. A sub n equals a sub n minus 1 times the common ratio. I need the common ratio, which is kind of necessary for the recursive. I need the first 5 terms, so 1, 2, 3, 4, 5. And I need the term named in the problem, a sub 9. So if you remember in the explicit formula, this is a sub 1 and this is r, so I know that my common ratio is negative 4. I also need a sub 1 in my recursive formula, so a sub 1 equals negative 2. So that is my recursive formula. A sub n equals a sub n minus 1 times negative 4, with a sub 1 equaling negative 2. My common ratio is negative 4. And if my first term is negative 2, and I'm multiplying by negative 4 each time, so multiply by negative 4, it gives me a positive 8, a negative 32, 128 times 4, let's see, 480, 512, 128 times a negative 4 is a negative 512. Okay, so the first 5 terms are these right here. And then the 9th term. So the 9th term is negative 2 times negative 4 to the 8th, because it's 9 minus 1. So negative 2 times negative 4 to the 8th, and that is negative 131072. And there you go. Number 30 just kind of switches, which is boring, but whatever. Okay, I need the common ratio. I need the recursive formula. I need the first 5 terms. And I need the 12th term. So I know the common ratio is the number being raised to the n minus 1, so that is 2. I know the first term is negative 4, so the recursive formula is a sub n equals a sub n minus 1 times 2, with the first term being negative 4, because that's in the explicit formula, that's the first term. So I know my first term is negative 4. I'm going to just keep multiplying it by 2, so times 2 is negative 8, times 2 is negative 16, negative 32, and negative 64. And then the 12th term is just negative 4 times 2 to the 12 minus 1, so to the 11th. So negative 4 times 2 to the 11th, negative 8192. So make sure you read the directions and you're answering everything that you're supposed to, or giving me everything you're supposed to. And that is page 3.